So we're going to do method A first. Both method A and method B start with assigning oxidation numbers. One nitrogen plus 3 oxygens equals -1, because the charge on nitrate is -1. Oxygen is -2, so this is -6. So nitrogen must be +5 for the left side to equal -1. Correct? So if you have a polyatomic ion, one of the atoms is going to be negative, the other one will be positive. Are we okay with that? So now you've got to identify which atoms changed oxidation number. Whose number changed? Cl. How many electrons did it change? 8. Did it gain or lose? Gain. All right. So nitrogen is the... Because it went from a +4 to a +5. So it lost... How many electrons did it lose? Yeah, lost 1 electron. Okay. So we've identified oxidation numbers. We've identified who changed in oxidation numbers. So we've done step 1. Step 2 says, using the change in oxidation numbers and formula subscripts, determine how many electrons are transferred. So we've partially done that. We said that chlorine gained 8. We said that nitrogen lost 1. What is the subscript for chlorine here? 1. What is the subscript for chlorine here? 1. What is the subscript for nitrogen? 1. And this one? 1. So, it says, and formula subscripts to determine how many electrons are transferred. If one of those numbers was different than 1, we would have to multiply by a factor. I'm going to show you in the next example how that works. For now, we're leaving those numbers alone, because the subscript, 1 chlorine to 1 chlorine, 1 nitrogen to 1 nitrogen. So, we figured out how many electrons are transferred. Number 3 says calculate the simplest whole number coefficient to balance the number of electrons transferred. So, what number does 8 and 1 both go into? 8. So what you have to do is multiply this one by 8 so that the number lost equals the number gained, which is what I told you has to happen for redox reactions, right? So nitrogen lost 1 electron, but it had to happen 8 times for the chlorine to gain them. And then what you do is you take that number and you put that number in front of the nitrogens. So whatever number you multiplied by, that is the coefficient. This is why we connect them with that line, so we know where the numbers go. So I'm going to need 8 nitrogen dioxides in order to give up 1 electron 8 times. Are you okay with this so far? Step 4. balance oxygen atoms using water, and then hydrogen atoms using protons. So what I want you to do right now, count how many oxygen atoms you have on both sides. Whichever one is deficit, you're going to add that number of water molecules to that side in order to balance out the oxygens. So how many oxygens on the left, how many on the right? Kyle? There's 20 oxygens on the left, 24 on the right. So who's missing, left or right? Left. So you're going to add 4 waters. So now they're balanced for oxygens. Now you have to balance for hydrogens. Count out how many hydrogens there are on the left, how many hydrogens there are on the right. The side that has a deficit, you're going to add the correct number of H plus ions.
How many H2O do you have?
4, sorry, yeah. We've got 4 waters. So how many H's do we have to add to the right-hand side?
4 H2s.
So now we should be done, so go back and check. Are we balanced for atoms? Are we balanced for charge? On the left-hand side, we've got 8 hydrogens on the right, 8 hydrogens. 1 chlorine on the left, 1 on the right. 24 oxygens on the left, 24 on the right. 8 nitrogens on the right, 8 nitrogens on the left. What is the total charge on the left-hand side? This is neutral, this has a 1 negative, this is neutral. So what's the total charge on the left? 0 plus 1 negative plus 0 is 1 negative. On the right-hand side, you've got -1 plus 8 negatives, so -9, plus 8 positives, so -1. So left side equals right side, this is balanced. And it says balance it in acid. Acid, H plus, right? We're balancing it in acid.
Could you change that and say like balance it in
Base? Yes.
So what would you do then?
You would take it one step further. I've balanced it like this. How many hydroxides would I need to add to neutralize those 8 H pluses? Yeah, but you have to add them to both sides.
So you'd add 8 to that side, 8 to that side?
Yeah, so we're at 8 OH minus, 8 OH minus. What does H plus and OH minus make? Water. So that would give me 8 waters. So 4 of them would cancel. These 4 would cancel out altogether. 4 of those would cancel out, and I'd have hydroxides on this side and water on that side. We'll do an example like that later. Okay. Method B. So we're going to do method A first. Both method A and method B start with assigning oxidation numbers. One nitrogen plus 3 oxygens equals -1, because the charge on nitrate is -1. Oxygen is -2, so this is -6. So nitrogen must be +5 for the left side to equal -1. Correct? So if you have a polyatomic ion, one of the atoms is going to be negative, the other one will be positive. Are we okay with that? Okay. So method B uses half-cell reactions. Who is reduced? Who is oxidized? Leo the lion says Gur. So who got oxidized? Deirdre? N in NO2. So we're going to write out half reactions. So our oxidation is NO2 going to NO3 minus. That means our reduction is ClO4 negative going to Cl negative. You have to write out the whole entire compound or ion that is involved in oxidation and reduction. So, step 3 says balance these two independently using steps 4 to 6. So, balance all atoms except for oxygen and hydrogen. So, is nitrogen balanced in the oxidation reaction? Yes, it is, WP, because there's the same number of nitrogens. Okay. Balance oxygen using water, and then hydrogens using H+. So we are deficit in oxygens on the left. So we're going to add 1 water to make it 3 oxygens. We are now deficit hydrogens on the right. So we're going to add 2 H pluses. So now we're on step 6, the last step for this one. Balance each side of the half reactions electrically by adding electrons. What is the total charge on the left-hand side? Saeed? 0. This is 0, this is 0. What is the total charge currently on the right-hand side?
0.
Nope. We've got a -1 charge.
Also 1 plus.
Yes, it's 1 plus because we've got 2 positives and 1 negative.
So add an electron.
We're going to add an electron to that side so that it is now balanced electrically. Now, sorry. Because there's no charge on water or NO2.
2H plus. Is that for the N?
The 2H plus is for the H's.
I'm gonna walk by the library and see Kyle grinding on chemistry.
There's 2 H's on this side now, so we have to balance them. So there's an equal number of H's on both sides. So you balance O's with water, you balance H's with H+. Okay? All right, now you're going to do the reduction. How many chlorines on the left? How many on the right? This is on your exam, Tamara.
Oh, so we just add H2O and then H2O
Yes.
and then
So how many waters are we going to add?
E4.
4. Because we're deficit. 4 oxygens. 8 H pluses. And now we have to balance for charge. We want
You put proton on that side?
Well, we've got protons on this side, so we can't add any more. This is a total charge of -1. This has a charge of -1. So if we can keep just that, charges will be equal. So we've got to cancel all of these. So how many electrons do you want to add? 8. Now, where you add the hydrogens, you're always going to be adding your electrons. Right? We had hydrogens and electrons. We're going to have hydrogens and electrons. So now, we are balanced for atom and balanced for charge in both of them.
Does it matter what method you choose?
Wow. If you were here at the beginning, you would probably say no. You pick. You pick which one you like
Alright, I
best.
take.
Okay.
Alright.
Like A? Mm-hmm. Me too. I learned this way. This is the only way I used in university.
B?
Nobody taught us the other way.
B is for nerds.
This is a lot of work. It
B.
works.
A is for the boys.
Okay. So now, number 7. Determine the least common multiplier of the numbers for the 2 half reactions. We need to cancel the electrons, so they have to have the same number. We've got 8 electrons here, 1 here, so you have to multiply this entire equation by 8. It's just like we were doing Hess's law.
Oh my god.
This is just meat.
So we have to multiply this whole entire thing by 8. So 8 waters, 8 NO2s, 8 NO3s, 16 H pluses, 8 electrons. Now you're going to add them up, just like Hess's law, and cancel anything that's on both sides. So for instance, we've got 8 electrons on the right, 8 electrons on the left. They're gone. We've got 8 H pluses on the left, 16 on the right. So we cancel 8 of them. Now you're going to write out your final equation. Oh, no, you're not. There's 4 waters here. There's 8 here, so that's 4. So we've got 4 waters, 8 NO2s, ClO4 negative, 8 NO3s, Cl minus, 8 H plus. So you have to double check to make sure you're balanced for element, balanced for charge. Does that match method A's answer? It should. So therefore we don't have to double check it because we already double checked A. Alright, so identify which elements gained or lost by connecting them. Which elements changed oxidation number?
ClO3.
These are fade friends right here.
ClO3 gain. Went up
So it's like that,
6.
right?
Yes. So this gained 6 electrons. What happened to I2?
She lost.
How many? Okay. Now, it says using a change in oxidation number and formula subscripts determine how many electrons are transferred. So this is what I was talking about the last period. Chlorine to chlorine, there's 1 each, so that's fine. That stays at 6. So here, we've got 2 iodines going to 1 iodine. So you have to balance the I. So we need 2 of these, which means we multiply that by 2.
Good morning, Spartans. And here are your morning announcements for Wednesday, June 13th. Required to attend today's practice.
What number goes
Rugby.
to 6 and 10 both going to?
The season will start on the 19th.
What?
Oh, is that,
What do they both go into? 30. Some of you might reach 30. Maybe. Okay, so what you're going to do, multiply each electron by whatever number takes it to 30. Then you have to put that number in front of the 2 species that are connected. So chlorine, gain 6. What do you have to multiply that by? 5. So then you have to say times 5 equals 30 electrons. And then you're going to put a 5 in front of the chlorate and a 5 in front of the chloride.
And then for the IO3.
So then the I...
6 in front of it then?
Yes, because we're going to multiply this by 3. This is already 2, so we're going to make that 6. And this one is going to be 3. You have to put that multiplier in front of the 2 species that changed oxidation numbers. So now, figure out how many oxygens you have on both sides. So we've got 15 on the left and 18 on the right. So how many waters do you want to add to the left side? 18 minus 15 is 3. So plus 3 H2Os, which means you're adding 6 H pluses to the right. So now, see if your charge is balanced.
where do you get the H?
Because it's positive, negative, and then negative.
You got it.
So we don't add any E.
No E's are added because we already took care of the electrons.
Where are the H2
We add it to balance the O's.
So you have